Multiplication of rational numbers. Find what 1/2 of 3/5 is. You might wonder, well, we said multiplication, why do we have the word of? Well, in this example, we're going to see that of translates into multiplication, but it shows us why. 1/2 of 3/5. So get the 3/5. 3/5. 1, 2, 3 out of the 5 pieces are shaded. 3/5. Now take half of that. So you cut it in half. And that leaves 1, 2, 3 out of how many pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which is 3/10, right? So just by looking at the shading, this turns out to be 3/10. Remember 3/10. Suppose you replace of with times. Notice if I replace the of with the times, I get 3/10. So when we use the word of in math, it translates into a multiplication. So in the future, just replace of with multiplication. Division with rational numbers. Just the way multiplication is repeated addition, division is repeated subtraction. So next time you read 3 divided by 1/2, you could translate it into how many 1/2s can I subtract from 3? And a mnemonic, a memory device, well, look at that division, almost looks like there's a little subtraction in there. So that will remind us that subtraction and division are related. So how many 1/2s can you subtract from 3? So here are 3, and I'm going to subtract halves. How many halves can I subtract? 1, 2, 3, 4, 5, 6. There's 6 halves. So 3 divided by 1/2 is 6. How about this one? This one's 3/4 divided by 1/8. So this would translate into how many 1/8 can you subtract from 3/4? Or if you want to say it, how many 1/8 are in 3/4? That's fine too. How many 1/8 can be subtracted from 3/4? When you have, unlike denominators, the first step should be to get a common denominator. And once you get a common denominator, the thinking becomes easier. Now you could see that this is asking how many 1/8 can you subtract from 6/8? Well, 6 of them. 1/8 and 3/4. So there's 6 1/8 and 3/4. An algorithm for division of rational numbers. When you see an algorithm, many times what it means, it's a shortcut. So this is a very shortcut for division of rational numbers, things that look like fractions when you divide them. All you have to do is put the first one on the top, a big division sign, that's this division, and then the second fraction in the bottom. The inner bracket and the outer bracket tells you what you should multiply. The outer bracket, 2 times 7, will give you the top number. 2 times 7 is 14. The inner bracket multiplication is 5 times 3. That'll give you 15. So 2/5 divided by 3/7 is 14 over 15. These are power rules. If you have a raised to the m times a raised to the n, you get the answer by writing the 8 one time and adding the exponents. A very important thing to remember here is that for this rule to work, you have to make sure the basis, the bottom number here, is the same. This doesn't work if these two bases are not the same. But if they're the same and you're going to multiply these two powers, we call these type of writing powers, you add the exponents. Here's an example. 3 to the second times 3 to the fifth. You copy the 3 only once, and you add the powers, 2 plus 5. So this is 3 to the 7th. Division, instead of adding, you subtract the top one minus the bottom one. Again, make sure that the basis, which is the bottom number, is the same, A. Okay, so I could apply this rule. Are the bases the same? Yes, both of them are 3. So I could apply this rule. It's the top power minus the bottom power. So 3 equals 3 to the negative 3. When you see a negative power, the simplest way to remember this, a negative power represents a reciprocal. You're going to turn this around. There's a 1 under this 3, and you're going to flip it around. Notice after you flip it around, the reciprocal, the negative goes away. And then 3 to the third is 3 times 3 times 3 is, which equals 27. So ultimately, the answer is 1 over 27. Here's another rule. If you have a number raised to a power and that raised to another power, you just multiply the powers. So here's 5 raised to the third and then raised to the second. Notice one way to remember visually is that there's a parenthesis between these two powers. There's a parenthesis between the two powers. So that's going to remind you, you're going to multiply. So this would be 5 to 3 times 2, which is 5 to the 6. This one reminds us that this power rule, that if you're multiplying two different numbers, notice these two numbers are different, you're multiplying. There has to be a multiplication. It doesn't work with addition. It has to be a multiplication or subtraction. Multiplication, all you have to do is distribute the power. The multiplication stays. So I'm going to distribute the power. I'm going to give the 2 a power of 4, and I'm going to give the x a power of 4. Now I'm going to simplify. 2 to the 4th is 2 times 2 times 2 times 2, which is 16. X to the 4th stays the same.